Welcome, friends. We are here to study or to discuss another new topic of power system, which is compensation in the power system. So, let us start this topic. What is compensation? What are the various types of compensation? Since this topic is a very advanced topic, so in this course, a very brief introduction of the compensation in power system will be discussed. Very brief, not in very detailed fashion, because this subject is a very advanced subject and it is specially designed for PG courses. So a very brief introduction, brief description of this compensation of the power system will be discussed in this course in next few lectures. So without any further delay, we are going straight into the topic. So we have power compensation in power system. Now we start this topic with a case study. Let us say we have this power system. Let us say we have this power system. This is a power system. We have 3 bus. We have bus number A, then we have bus number B, then we have bus number C. Now we have generator G1 and we have generator G2. 2 generators we have. Now generator G1 is generating a power of 300 megawatt and generator G2 is generating a power of 200 megawatt. There, this is generating. Now we have a load at bus C. So we have a load at bus C. Which is equal to 500 megawatt. So in this case, we have total power generation which is 500 megawatt, and total load is also 500 megawatt. So we consider this one to be a lossless system. Now we have 3 transmission lines. We have transmission line. This is line number A to C connected between bus A and C, which is delivering 200 megawatt of power. Another line connected between A to B, bus A to B is delivering 100 megawatt of power. And third line is connected between B to C, is delivering 300 megawatt of power. So this is a case study of the power system. Now the problem with this line that connected between A to B is that the steady state stability limit of the line is 80 megawatt. This is the problem. Now what is steady state stability limit? I am coming in a moment. It means that it can transfer maximum 80. That means it is the capacity, highest capacity. Okay, this is the highest capacity of that line. However, due to some issue, this is carrying 125% power. That means 25% more power than its rated capacity. So that line AB is overloaded. That is a problem. Line AB is overloaded by an amount of 125%. So what will be the immediate consequence? The consequence will be it will affect the total it will be affecting the line straight away, its thermal stability. That means line conductors will be heated to carry excess amount of current, and then heat will flow, then conductor will be getting heated up, then the life of the conductor will be reduces, and so on, so on. Also, it will affect its stability limit. So there are lots of issues. So if a line is operated with overload capacity, then there should be a bad consequence of that. So to solve this problem, so if we need to send really the maximum amount of power, which is 80 megawatt, then this excess, that is 20 megawatt power is excess, 20 megawatt power is excess or extra, we need to cut that load from the load end, from the consumer end. We need to cut that load. This is a probable one solution. So solution number one may be limit any line within its loadability limit. One solution may be the extra load, which is 20 megawatt in this case, must be cut. So that will directly affecting our load side. Okay, so a lot of power cut situations will be observed. Now, is it the only way to tackle this problem? Can we think of an alternate solution? To answer this, an alternate solution could be, let us place a capacitor in series with line AC. Okay, this is a capacitor C. Let us place a capacitor. Now, due to the placing of that capacitor in series with the line AC, so a capacitor is connected in series with line AC. That is very important. Let us see what happens after that. Now, it can be seen that the power flow that is drastically changes. Now, initially the line AC was carrying 200 megawatt power without the capacitor, but the moment the capacitor is placed in series, then the power transferring ability is enhanced by 30 megawatt. So now it is transferring 230 megawatt of power. So the generator G1, which was generating 300 megawatt of power, now 230 megawatt of power is carried by line AC. So rest 70 megawatt of power is carried out by line AB. So since line AB is carrying 70 megawatt power, which is less than its steady state stability limit, that is maximum ability of its power carrying capacity, so we can say that it is now perfectly all right for every aspect. Okay, so line AB rather, it is within its loadability limit, steady state stability limit does not violate. Also we have connected a capacitor, so everything will be all right, and most importantly, we should not cut any load. The load demand has been fulfilled, that is 500 megawatt. So in this case, what happens is that line AB carries 70 megawatt of power. Line BC or rather line AC line AC carrying 230 megawatt of power. Now these two will be 300 megawatt, will be generated by generator G1. Now again line BC is carrying 270 megawatt of power. Now from where this is 270 is coming, it is this generation 200 megawatt from generator G2 and this 70 megawatt from line AB. So these two makes it 270 megawatt, and this, you see, this 270 megawatt BC and this 230 megawatt AC is reaching at load. So 270 plus 230, it is 500 megawatt, it is matching now. The problem is solved. So most importantly, what we have done, we have just connected a capacitor in series with the line AC. So what happens? Before C, the line AC was carrying 200 megawatt power and line AB was carrying 100 megawatt of power, which is not accepted, which is violating the loadability limit of that line. Now after the inclusion of C, what happens? Now AC line carries 230 megawatt of power and AB line carries 70 megawatt and power, so which is perfectly acceptable. So what happens here is that this on inclusion of this capacitor, this power transfer or power carrying capability of the line AC enhances. So one important observation we can have from here is that line AC carries more power with C connected in series. So now why? What is the reason? Now what is the reason or what is the relation with this C? Means why the power will be increased or power transfer will be increased with the inclusion of the C? What is the reason? Now let us have this equation. The power flow from one end to the other end is given by this equation. Now let us consider this power system. We have a transmission line having reactance of Jx. We are considering lossless system. We have the generator voltage at E delta. E is the magnitude of the generator, voltage magnitude of the generator, and we have a load. The voltage magnitude of the load is V. Now this delta is called the load angle. So if you term this bus as A and this bus is B, so bus A and B are separated by an angle of delta. So if generator is feeding the P amount of power from A bus to B bus, that means from generator to load, that means this P is numerically equal to EV by X sin delta. EV by X sin delta. For the time being, you please consider this equation. It can be derived, but that is the beyond of the scope of this course, power system 1. So P is equal to EV by X sine delta. Now this is the modified diagram. This is the modified diagram. The same power system having generated G1, having the impedance, having the voltage E delta and the load having the voltage of V0. The same, the power is being fed from the generator to the load. Now the capacitor is being inserted. Now what happens is that since this capacitor is connected in series with the line, then the net reactance now becomes X minus Xc. Net reactance now becomes X minus Xc. So that is exactly written in the denominator. Now if you compare these two equations, you see this. So let us say this is equation number 1 and this is equation number 2. Now as contrast with the equation number 1, the denominator of equation 2 reduces. The denominator of the equation 2 reduces. So if the denominator reduces, so the result will be increasing as quite naturally. So this is the reason on inclusion of the capacitor, power flow increases. That is the explanation and that is the answer why power flow increases with the connection of the capacitor in series. That is the explanation, because the reactance gets reduced. Which comes in the denominator of the expression. Since the denominator gets reduced, so the result P is increased. So it offers a variable reactance. It's offer a variable reactance to control the flow of power. It's a very important statement. It offers a variable reactance. Why? Because initially it was X, but now on the inclusion or with the capacitor, now it becomes X minus Xc. So reactance is changed. So it offers a variable reactance. So from X to X minus Xt. So with that, what happens? We can control the flow of power. So initially it was, let us say it was P1. Now let us say it is P2. Naturally, P2 will be greater than P1. Now, one important information from that. Now, since this curve or this equation has a sine term, then if we plot in x-axis we have delta and in y-axis we have P, so it will simply follow a sine curve. And that will be the maximum power. And it occurs at delta is equal to pi by 2. Simple. Because at pi by 2, sine pi by 2 is 1. So this point is the maximum power. Right? This point is, so this shaded point is the point of maximum power. And the maximum power beyond this, it is not possible to transmit anything beyond this. So so delta is equal to pi by 2, it is the P max. It is called, this point is called actually steady state stability limit. Steady state stability limit. So now This is a brief idea. What is the compensation? Now, compensation literally means to compensate something or to make change. So what is that change? We can control the flow of power. That is the change. Okay, we can change the control of flow of power. So suppose we have this change. How you make this change? The answer is you make from x to x minus xc. You make this change. If you make this change, x from x to x minus xc, you will get p1 to p2. This is called compensation. So what is compensation? Compensation in power system is the process by which power flow can be controlled. Power flow can be controlled, and when I say power flow, it does not necessarily mean that only active power. It both active and as well as reactive power flow can be controlled either by controlling voltage at different buses. So number one parameter is voltage. So it will be, first one is voltage control, or by controlling impedance, or by controlling impedance or reactance, as we just see, or by controlling the angle also, that is the delta. By these three way we can control the flow of active power and reactive power. We can control or we can change the flow of active and reactive power. So this is the compensation. So it is the process by which power flow can be controlled by controlling these three parameters, whether it could be either it could be voltage controlled, or it could be impedance or reactance control, or it could be delta controlled or angle control. Now always it is customary that either an inductor or capacitor is necessary to do that. An inductor or capacitor is necessary mostly, but resistance will also work, but mostly inductance and capacitance will be necessary to do this or to achieve this, okay, to control these parameters. Now let us coming back to this again. Suppose we have this power system. Let us say we have two bus. We have two bus system, and we have a capacitor, and we have a transmission line. And now we have a sudden load connected. We have some generator. We have some generator connected here. Right. We have some generator connected here. Let us say this is bus number A, and let us say this is bus number B. Now what does this capacitor do? What does this capacitor do? It will inject some reactive power. It will inject some reactive power. Due to which, okay, I am not talking about the reactive power. Let us say by this capacitor, X becomes X minus Xc. Okay. So power P1 becomes P2. Now this enhanced, let us say this is enhanced by 20%. Let us say, just for an example, our x becomes x minus xc, so my p1 becomes p2, and this increment p2 naturally increases. So this enhancement, let us say it is enhanced by a factor of 0.2 or 20%. Now let us consider for a time being, let us consider we require only 110% power. That means it is desired to have 10% more power, but instead of having that, we are having what? We are having 20% more. So where this 10% will go? So the answer to this, is that you don't have to generate 20% more power. We can control the reactance of this capacitance even in a smarter way. That is by automatic control, by adopting automatic control. How is it that so? Now the answer to that, we must incorporate power electronic based switches like IGBT, like SCR. If we adopt power electronic based switch, then whatever we require, we will get. That means that is called automatic control. We don't have to think about it. It's not about any manual. How this scheme will work? Let us say we require 10% more power. It will send a command, and that command will do something, and it will send pulse to SCR. And that SCR will be fired at an angle of alpha as per this requirement, 10%. And if SCR is fired at alpha, it will be that thyristor is switched on at some angle alpha, and it will be inducing a fraction of Xc. Okay, that means what I mean to say is here that whatever Xc was injecting, whatever Xc was added previously, it was full Xc. But with the help of power electronic based switches, now the Xc becomes a function of alpha. With the help of that, if this alpha can be controlled for the different values of alpha, different values of Xc can be set. Whether it could be 0.1 Xc, it could be 0.3 Xc, depending on the requirement. Okay, That means we require the automatic control. We are from the manual automatic control. We require power electronic based switches like IGBT, SCR, something like that. So with this, I repeat this. So what is compensation? Compensation is basically the controlling of the flow of active power or reactive power. How? Either you need to control voltage, or you need to control reactance, or you need to control angle. Because you see from this expression, this P expression, it is a function of three variables: voltage, reactance, and this angle. So either we can control voltage, or we can control reactance, or we can control angle. By controlling these three, we can have the control of active power as well as reactive power. Now, how we can control? We can either control manually by putting an inductor or a capacitor. An alternative, or maybe sorry, you can say a more advanced solution is that we may adopt, or we must adopt, power electronic based switch. Then the reactance, whichever is offered by that inductance or capacitance, it will be added by a fraction, only 10% or maybe 20% or maybe 50% as per the requirement of our need. It will send the signal as per the requirement of the need. It will send the signal to the SCR, and SCR will be fired by appropriate angle, that is the delay angle or firing angle. In this way, automatic control will be achieved. So till now, a brief introduction of compensation is discussed. Now in the next section of this topic, we shall discuss the classification of the compensation. That means types of compensation and their working principle. So with this, I am ending here. Thank you.